Hello everybody. In this video we're going to be covering one of the sections in chapter 5 of our text, molecules and compounds. So let's discuss how we would write out the formula for an acid if we were given just its name. So when the name ends in acid, that's our indicator that we're dealing with an acid, and that our formula should start with a capital H. The hydro prefix means that it's a binary acid, and if you don't see a prefix, it means that it's an oxyacid, which seems a little confusing at first. Where does this hydro coming from? For a little bit of context, the hydro really means water, and it comes from the fact that binary acids were originally prepared by taking the gases of nonmetals and bubbling them through water. So it was when you added water to those gases that you got the binary acids. For an oxyacid, if it is ending in ic, the polyatomic ion that it has in it ends in 8. If the ending is us, the polyatomic ion that it contains ends in ite. So let's go through a couple of examples here. So if we were given the name hydrosulfuric acid, first we need to write the symbol for the cation and its charge. So it's an acid, so it's always going to be H+. Then we need to write the symbol for the anion and its charge. We see that we have the hydro there, so that means that it's a binary one. And so then we look at sulfuric, that's going to mean sulfur. We need to do our charge switching that we did before. And we'll come up with H2S. We add the aqueous symbol to indicate that it is in water. And again, also we don't need to reduce these because we got 1 and 2, right? And then we'll check that the total charge works out. So for hydrogen, we got a +1 charge. We got 2 of them. That's a 2+ charge. For sulfur, we have a -2 charge in one of them for -2 charge, giving us a net 0 charge. Let's look at the oxyacid now, carbonic acid. First, we're going to write the symbol for the cation and its charge. Again, for all acids, that's going to be an H+. Then we'll write the symbol for the anion and its charge. We have no hydro, so that means that we're dealing with a polyatomic, and it ends in ic, which means that we need to replace that ic with an 8. So we need to look up the carbonate polyatomic in our table. We're going to switch our charges for subscripts and come up with H2CO3. We add our aqueous symbol there. And finally, we check our charges. Again, we have those 2 hydrogens to counterbalance the -2 charge on our carbonate polyatomic. Let's do another example now where we have sulfurous acid. So remember that we have to pay attention to this ending here, that this is an us and not an ic. Again, we're going to have our H+ for our cation. We got no hydro, so we know that it's a polyatomic. Us means ion, so we need to look up the sulfite polyatomic. That's SO3 2-. We do our charge swapping. We come up with H2SO3. Remember that we do not need to reduce this because this would be 1 and 2 here. We add the aqueous symbol. And then we check our charges to make sure that we have a neutral species. I'll give you guys the opportunity to do a little practice here. Chlorous acid, phosphoric acid, and hydrobromic acid. So chlorous acid, we come up with chlorite. We're going to pair that with H plus, and we come up with HClO2. Phosphoric acid, we have our PO4 3 minus. We're going to need 3 hydrogens to counterbalance that, H3PO4. And we'll remember that hydrobromic, we're going to go to the bromine or bromide ion, anion. We're going to need 1 hydrogen to balance that out, HBr. Now we can discuss how we're going to go about naming binary acids when we're given the formula. First, we're going to write the hydro prefix. We're going to follow with the nonmetal name. We're going to change the ending on the nonmetal name to "ic." We're going to write the word acid at the end of the name. So let's look at an example of naming a binary acid. We start off with the formula HCl. First, is it one of our common exceptions? It is not. We identify the major class as acid because it has the presence of the H at the beginning. And we identify it as a binary acid because there's no polyatomics here. First, we're going to identify the anion. We know that this Cl here is going to be Cl minus because it's in group 17. We're going to change the chloride here to chloric. And we're going to add the hydro prefix, hydrochloric. And finally, we put the word acid at the end, so we have hydrochloric acid. If the for naming oxyacids, if the polyatomic ion name ends in 8, then we're going to change it to ic. So 8 goes to ic. If it ends in ite, it's going to go to us. So ite and us. Then we're going to write the word acid at the end of all the names. Let's take a look at this one. H2SO4. Is it one of our common exceptions? No. We've identified the major class. It is an acid. We know that because it starts off with an H. It doesn't have to be a lone H. Is a good thing to realize here. It could be H2 or H3. And then we're going to identify it as an oxyacid because of the presence of our polyatomic ion. We need to identify the anions. We have SO4, which is SO4 2 minus, or the sulfate polyatomic. We need to change the 8 to an ic in this case, so sulfate becomes sulfuric. And we're going to write the name of the anion followed by the word acid, sulfuric acid. So if we followed this perfectly, it would actually be sulfic acid. And traditionally, they just always made it sulfuric acid, which is kind of an exception, and it just kind of makes it sound a little nicer, I guess. Let's do another example. This time we have H2SO3 instead of SO4. Is it one of our exceptions? Nope. We can see that it's an acid, just like the other one. And we can see that it has this polyatomic SO3 in it, so it's an oxyacid. We identify the anion. This time we have SO3. It still has a 2 negative charge, but it's called sulfite. Following our scheme here, we're going to change the ite to an us. So now sulfite becomes sulfurous. And then we write the word acid at the end, and we get sulfurous acid. Let's see if we can do a little practice here. H2S. That's hydrosulfuric acid. HClO3. So we have the chlorate polyatomic there. And we get chloric acid. And HNO2. becomes nitrous acid because we have the nitrite polyatomic.